High above the Arctic, a swirling mass of cold air spins like a top. This is not just any ordinary weather phenomenon, it is a powerful and majestic force of nature. This is the polar vortex, a natural feature of our atmosphere. It is a large area of low pressure and cold air surrounding both of the Earth's poles. It acts as a giant refrigerator, keeping the coldest air locked away in the Arctic region. This containment is crucial for maintaining the climate balance across the globe. The polar vortex is strongest during the winter months when the temperature difference between the equator and the poles is greatest. This stark contrast in temperatures fuels the strength of the vortex, making it a formidable guardian of cold air. It usually stays strong and stable, keeping the Arctic air from plunging south. This stability is essential for preventing extreme cold air from reaching lower latitudes, which could cause severe weather conditions. The polar vortex is held in place by a delicate balance of atmospheric forces. These forces include the jet stream, which acts like an invisible barrier, and the Earth's rotation, which helps to keep the vortex in a steady spin. These forces keep the vortex spinning high above the Arctic. The continuous motion of the vortex is a testament to the dynamic and ever-changing nature of our planet's atmosphere. But sometimes this balance can be disrupted. Factors such as sudden stratospheric warming or changes in the jet stream can disturb the stability of the polar vortex. When this happens, the polar vortex can weaken, shift, or even split into smaller vortices. These disruptions can lead to unusual weather patterns, bringing colder temperatures to regions that are not typically affected by Arctic air. The impact of a disrupted polar vortex can be felt far and wide, influencing weather patterns across the northern hemisphere. Understanding the polar vortex and its behavior is crucial for predicting and preparing for these changes. Scientists continue to study the polar vortex using advanced climate models and data analysis to better understand its complexities. Their research helps us to anticipate and mitigate the effects of a changing climate. The polar vortex is a powerful guardian of cold air, a testament to the intricate and interconnected systems that govern our planet's climate. Its presence reminds us of the delicate balance that sustains life on Earth. Recent observations show that the polar vortex is starting to behave unusually. It is showing signs of shifting and stretching, indicating a weakening of its normally tight structure. This weakening allows the cold air that it normally traps to escape. This shift and stretch of the polar vortex are causing concern among meteorologists. They are closely monitoring the situation, using sophisticated computer models to predict the path of the escaping Arctic air. The latest forecasts suggest that the weakened polar vortex will allow a surge of Arctic air to break free and plunge southward. This frigid air mass is expected to head towards North America, bringing with it the potential for a significant cold snap. This movement of Arctic air is not uncommon, but the intensity and timing of this particular event are unusual. It serves as a reminder of the power of the polar vortex and its potential to impact weather patterns far beyond the Arctic Circle. The arrival of this Arctic air mass is expected to bring a dramatic drop in temperatures across much of the central and eastern United States. Daytime highs could plummet to well below freezing, and overnight lows may reach record-breaking levels in some areas. In addition to the bitter cold, this Arctic blast could also bring a round of springtime snowstorms. The combination of cold air and moisture could create ideal conditions for heavy snow, potentially disrupting travel and daily life. Section 5, a note of uncertainty, forecasters urge caution. While the forecast models are pointing towards a significant cold event, it is important to remember that weather forecasting is not an exact science. The exact track and intensity of the Arctic air mass are still subject to change. Forecasters are closely monitoring the situation and will continue to provide updates as new information becomes available. It is essential to stay informed about the latest weather forecasts and to be prepared for the possibility of extreme cold and snow. Section 6. The spring thaw, a battle between winter and spring. Even as this Arctic blast threatens to bring winter-like conditions, it is important to remember that spring is just around the corner. The warmer temperatures and longer days of spring will eventually win out, pushing the cold air back north. The arrival of spring will bring a welcome respite from the cold, but it may also bring its own set of weather challenges. The clash between cold air and warm air can create volatile weather patterns, leading to thunderstorms, heavy rain, and even tornadoes. Section 7. A look back. The sudden stratospheric warming event. This chapter delves into one of the most intriguing and impactful meteorological phenomena of recent times. This is not the first time this winter that the polar vortex has made headlines. The polar vortex, a large area of low pressure and cold air surrounding the Earth's poles, often influences winter weather patterns. Earlier in the season, a phenomenon known as sudden stratospheric warming caused a significant disruption to the polar vortex. This sudden stratospheric warming occurs when rapid temperature increases in the stratosphere, the second major layer of Earth's atmosphere, disrupt the usual flow of the polar vortex. This event led to a period of unusually warm weather across parts of the Arctic. The warming in the stratosphere can cause the polar vortex to weaken or even split, leading to dramatic changes in weather patterns, and contributed to a more active storm track across the United States. This increased storm activity can result in severe weather events, including heavy snowfall, ice storms, and even extreme cold outbreaks in regions that are typically milder. Sudden stratospheric warming events are relatively rare, occurring roughly every 2 years, but they can have significant impacts on global weather patterns. Scientists and meteorologists closely monitor these events to better understand their causes and predict their effects, but they can have significant impacts on global weather patterns. The ripple effects of a sudden stratospheric warming event can be felt far beyond the polar regions, influencing weather systems across the globe. While the effects of this earlier event have largely subsided, the memory of its impact lingers. It serves as a reminder of the dynamic and ever-changing nature of our atmosphere. It highlights the interconnectedness of our atmosphere. The atmosphere is a complex and interconnected system where changes in one region can have far-reaching consequences, and the potential for unexpected weather events. As we continue to study and understand these phenomena, we gain valuable insights into the intricate workings of our planet's climate system and the potential for future weather surprises. Section 8. A return to normalcy. The expected rebound of the polar vortex. The polar vortex, a large area of low pressure and cold air surrounding the Earth's poles, is a crucial component of our planet's climate system. It typically weakens and strengthens in a cyclical pattern, influencing weather far beyond the Arctic. Despite the current disruption, the polar vortex is expected to regain its strength and stability in the coming weeks. This cyclical nature is driven by various factors, including the temperature gradients between the equator and the poles, as well as atmospheric wave patterns. When the vortex is strong, it keeps the cold air locked in the Arctic, but when it weakens, it can send frigid air southward, affecting weather in North America, Europe, and Asia. As the northern hemisphere transitions into spring, the temperature difference between the equator and the poles will decrease, leading to a strengthening of the polar vortex. This seasonal transition is marked by longer daylight hours and gradually warming temperatures, which help to stabilize the atmospheric conditions. The interplay between the warming equator and the still cold poles creates a dynamic environment that can either strengthen or weaken the polar vortex. This means that the current cold snap is likely to be temporary. As temperatures rise and the polar vortex regains its strength, we can expect more typical spring weather to return. However, these temporary disruptions serve as a reminder of the complex and interconnected nature of our climate system. The melting snow and thawing ice are visual indicators of the changing seasons and the shifting balance of atmospheric forces. However, it serves as a reminder of the power of the polar vortex and its ability to influence weather patterns across the globe. The polar vortex is not just a local phenomenon, its effects can be felt thousands of miles away. When it weakens, it can lead to extreme weather events, such as severe cold snaps, heavy snowfall, and even disruptions in jet stream patterns. Understanding the polar vortex is crucial for meteorologists and climate scientists as they work to predict and mitigate the impacts of these weather events. As we continue to learn more about this fascinating atmospheric phenomenon, we can better prepare for its impacts and appreciate its role in shaping our planet's climate. Advances in satellite technology and atmospheric modeling have provided us with unprecedented insights into the behavior of the polar vortex. By studying these patterns, scientists can develop more accurate weather forecasts and climate models, helping societies to better prepare for and adapt to the challenges posed by extreme weather events. The polar vortex, with its immense power and influence, remains a key area of study in our ongoing quest to understand Earth's complex climate system.